The boys, they're building this year. We'll say that. How's that sound? The girls,
I heard the football team went to state.
we did.
My old football team went to state. I was glad to
Be in a good school. Yeah, our coach is the announcer for the office.
For real? That's cool.
I'm a Steelers fan. You know what the Steelers are right now? They're sitting at home watching the playoff games.
I feel your pain. The Cowboys lost to LA. They should not have. That was big.
I feel like if you were one of the announcers and stuff, you can make a bunch of puns during the game. Short hair.
All right, my friends. Let's talk about anything we came across on 8F that you might have a question about. Number 9. We only had to do evens, but we'll hit 9 anyhow. This one, is that what you're looking at? So this is a problem that we didn't have to do last night, but we can do it anyhow. It won't hurt us. All right, so this is the same thing as the fifth root. The fifth root of negative 32 squared. So I would not go about squaring 32 and then taking the fifth root. I know that 32 is 2, 4, 8, 16, 32, so 2 to the fifth. So the fifth root,
So you can take it to
the fifth root of this is negative 2, and then I'm going to square that, so I'm going to get 4. What else do we see on our review that we'd like to go?
17.
17. Yeah, we're hitting all the odds. We didn't have to do odds, but good.
It's a review.
All right, I'm with you. Dude, I'm with you, man.
Yeah, man.
I knew that you were like, you work hard to get that A minus or your B plus or your C minus.
No. You said A plus.
You got an A plus, yeah.
That's what you heard, no?
All right, solve the equation, rounding answers to nearest hundredth when appropriate. Okay, so if I wanted to just solve this, I can't get this into the same base on both sides because I got x plus 3 as base. So I'm going to take the fifth root of this side, the fifth root of that side. Is that okay so far?
Yeah.
So then on the left side, that gives me x plus 3. And on the right side, that gives me negative 2 because negative 2 times itself 5 times is negative 32. Subtract 3, so I get negative 5. There you go.
That was okay, yeah.
What else would you like to see? What you got? Speak.
Forever.
24.
24. And come back out to use old homework, grab yours, pass on the rest. And 24 is going up on the board here in a moment.
24 is easy. 25 more.
Okay, well, we'll do both if you want. I don't care.
That's what I was like.
24. Review. 24 is 7 raised to the 3/5. And then that's raised to the negative 5 over 2. Simplify the expressions. Answer should be in the same form as a question, so we'll leave it as exponent form. Denominator should be rationalized in simplified radical form. No negative exponents. Okay, so I have power to a power, so let's just multiply our exponents. So I'm going to get 7 to the negative 15 over 10. Is that okay so far? Which is the same thing as 7 to the negative 3 over 2, which I don't want negative exponents, so I'm going to do this. 7 to the 3 over 2 power. I think I'd leave it like that. The answer might be off a little bit, but I'd take that for an answer. What else?
25.
25, and then we'll go back to what? 20. Go back to 20, so 25 then 20. All right, 25. 25 C is, okay. 3 to the 1/2, yay. Times 5 to the 1/2, yay. Over 15 to the 1/2, double yay. That's 1/2, I'm putting 1/5, I'm sorry. And then that's to the 4/3 power. All right. So B and I am to the same. So you have to understand this. This is the same thing as this. Is that okay? And that's the same thing with 5 to the 1/2 is the same thing as this. So if I'm multiplying, that means I can multiply under. So I'm going to get here on top, I'm going to get 15 to the 1/2 power. On bottom, I'm going to get 15 to the 1/2 power. And then that's raised to the 4/3 power. But 15 to the 1/2 and 15 to the 1/2 look like the same thing. So that answer inside has to be 1. So I get 1 to the 4/3. which is also 1.
Wait,
20.
what? Why would it be?
Never
I think you can't multiply different values.
So this is the reason you can. So I can say root 3 times root 5. That's totally legitimate. So that's basically what that is. Okay? 20. Yep. 20 says 3x plus 1 squared equals 1 over 9. Yes?
Yeah, God.
All right. So I'm going to take this and make it 3 to the negative 2 power. Is that okay? So now I have like bases on both sides. So power to power, I'm just going to multiply those together. And I made an error yesterday, so I need to make sure I correct that. So power to power, you multiply the exponents. That doesn't mean I'm going to FOIL out x plus 1, x plus 1. It means I'm multiplying the exponents. That's going to give me 2x plus 2 equals negative 2. Subtract 2. So x equals negative 2. And then there was one yesterday we did, I can't remember, it was done as a quadratic formula. It was totally wrong. I'm sorry. I got to quit, falling down the stairs before I teach class.
For real.
Anything else you'd like to take a look at?
33?
2-3?
No, 33.
33? Alright, 3x to the 1/4 y to the 2 over 3 z over 2x y to the 1/2. Whole thing's raised to the second. Okay. I would probably work from the inside out. 3 over 2 is not going to reduce at all. Things to know. So I have this and this. So I'll do a tug of war. So that's 1/4 minus 4/4. So I get negative 3/4. That means I have an exponent on bottom. So that's going to be x to the 3/4 on bottom. Is that okay so far? The 3 over 2 is going to stay as is for right now. And then the 2/3, I'm going to go 2 over 3 minus 1/2. So that's going to be 4 minus 3 over 6, which is 1 over 6. So I get a y to the 1/6 on top, and then z is up on top, and then I have that squared out there. Does that look okay so far? Everyone happy?
Yep.
Always happy.
Always happy. All right, let's square everything. So I get 9 over 4. Y, if I square that, 1/6 times 2 is 2/6, which is 1/3. Then z to the second. And if I multiply those together, I get 6/4. 6/4 reduces to 3 over 2. Is that good? There's my answer. Any others? Going once? Twice? Sold. All right. Let's do this. Why don't I collect that one tomorrow? Because that's the review.
Big facts.
Is that okay?
Oh, yeah.
We have a quiz tomorrow. So remind me tomorrow. Don't be like, dude, sir, if you didn't collect this, remind me tomorrow. Yeah.
You do 38 real quick.
38 real quick, sure. Last one, and then we're done. 38. X to the 7 over 4. Y. Z to the negative 2 over 5. Over x to the 3/4, y to the negative 1, z to the 3/5. That one?
Yes, sir.
Yeah, boy. All right. So it looks like I can do tug of war between these. So I got 7 over 4 minus 3 over 4, which is 4 out of 4, which is 1. So I get x on top. Let's move that up. So I get y squared now. So that moved up. We're going to move this one down. So then I get 3/5 and 2/5 added together when I move it down. So that's 5/5. So then I just get z. Done. All right, so put that one away. I will collect that tomorrow. Maybe put a note on top saying, make sure Stirrup collects this or else. Sunflower seeds today. Love it. In a little bit. It's going to be hard to teach when I'm just spitting them. People in the front row kind of get offended when they start getting hit with shells from my mouth.
Thanks, man.
Though it's kind of funny.
People to like spit seeds at other people when driving their car, so you're on the highway going like 80 miles per hour and you guys spitting crap.
Okay, this next stuff will not be on the quiz tomorrow, but here's the nice thing. Everything you learned about parabolas and how parabolas would go right, left, up, and down is the exact same thing.
We need one more, Stuart.
Huh?
We need one more. Yeah. Thank you.
I'm just trying to get me to drop her grade a little bit. Just kidding. So everything you learned about parabolas, and I'm just going to put this down. So you remember a parabola, for the most part, look like this, right? Well, if I did this, that means the whole thing would shift up 5 and do this, okay? And if I did this, that means the whole thing shifts to the right. Remember, it's always opposite of what you would think. And then you can start incorporating. And of course, if this was a subtraction, the whole thing would shift down. If this was addition, it would shift left. Remember all that?
Yeah.
And then the number out front, that dictated whether it opened up or down. If it was negative, it opened down. And it also made it squeezed, made it real skinny or real fat. If it was real skinny, if it was a big whole number, if it was a fraction between 0 and 1, it made it fat. Okay? So the nice thing about that leads into what we're doing with today. So we're talking about different things. So letter A, this is exactly what we just showed. Letter A is x squared, so it's the black one. Letter B is going to be the red one, so it's x plus 3 is a quantity squared, so it shifts to the left. Remember, if it's in parentheses, it always shifts opposite. That's also going to be the same if it's under a radical altogether, it would shift opposite. C flips upside down because it's a negative out front, and then it shifts up 4 because we added 4 to it. And then letter D, the green one, it shifts to the right because we subtract a 5 from groups, and it shifts down 3. So those are all of the things that take place with a parabola. And again, these rules are all going to apply the same way. Again, remember that's our standard form of parabola. That's vertex form. If it's in that form, you can find the vertex pretty easily. If you don't have the vertex there, you can use negative b over 2a if it's in standard form. Plug that back in and find the other one. All right, so can I move off this?
Yeah.
Kind of review. I think you've seen that once. I think I taught it once, but it might have been just a really bad dream. All right, so what is the relationship between y equals x squared and the square root of x? Well, think about if I took the square root and then took the square root again is how I'd get from x squared to square root x. So I took the square root of x squared, I get x, take the square root again. Okay? So that's kind of, is that really important and vital? I don't know. But then we have to determine and they're saying, hey, this was an inverse. These are inverse functions of each other. We're doing opposite operations. One I'm squaring, one I'm square rooting. And then we have to think about this one. We have to limit it. So right now, my domain of my blue line, I can go forever to the left to forever to the right. Do you agree with that?
Yeah.
Okay? But think about this. If I were to make, and we'll just do a simple t-table off this one. What's the smallest number I can plug in for x if I had to square root x? Yeah. Does 0 work? No. Can I have square root 0?
No. 1.
Square root 0 is? 0. So I can. Can I have a square root of a negative number? Well, then we start dealing with I, right? So, and then if I plug 1 in, what's the square root of 1? 1. And then it's nicer when we do perfect squares, so the next perfect square after 1 is 4. So if I plug 4 in, square root of 4 is 2. So if I were to graph this, I get 0, 0, 1, 1, and then 4, 2. So this graph looks like a part of a parabola. Okay, this one has a starting point, and it doesn't end as it goes to the right. So think about what this domain would do. This domain, I can start square bracket at 0, because I include 0, and it goes all the way to infinity. So the inverse function of x squared is the square root of x, the inverse function now has a restricted domain. And the best way when you go through these is you have to realize, okay, what's my domain of my original? Then what does the restricted domain of the function become? Okay? Does that seem okay so far? Anybody lost? No. Again, I was just basing this off of a t-table. Let's see what we have down here. It says we have reviewed that the domain of the function is, what is the range? So the range of the parabola would have went from 0, square bracket, to infinity. And then the range of this starts at 0 as well. And it's going to continue to grow up. It's going to grow to the right faster, but it's going to continue to grow up. So notice our range on both of these is the same thing. You have the same starting point. When we graph y equals root x, what would the domain and range be? Well, we've already listed them. So domain here, range here. Cool? Okay. Now move on. And I might be able to get done and tell you guys a little funny story. Good one. It's a good one. All right. So this one here, we've done in purple. This is kind of the parent function. Okay, that's the minimum that you could graph. Okay, that looks similar to what we just graphed on the last one, right? Okay, so what does this, in your opinion, of what you know, I have root x, but then I'm adding 4, and the adding 4 is outside the radical. So do you think it shifts up, down, right, or left? Outside the radical, so it's not grouped. Up. Up how many? 4. Is that okay?
Yeah.
And then the red one, this is now grouped. Okay, I have root x minus 6. X minus 6 is grouped. Technically, I could put that in parentheses. I don't need to, but it's happening under the radical. So does this shift up, down, right, or left?
Right.
Right how many?
6.
6. So right 6. Looks like that. Okay. And then, oh, you can't really see that one. That is y equals negative x raised to the half. And I have to do this one in blue. I can't flip that one over. That might be a little trick. Blue. So that's y equals negative x to the half, which is the same thing as saying y equals the square root of negative x. Now, hang on. Before you jump on me, my case on this. Can I have a variable be negative under a radical sign?
No, unless it's measurement.
What numbers could I plug in?
Negatives.
What I can plug negatives in. If I plug negatives in, does my under the root become positive?
Heck yeah.
Okay, so this one just takes the graph and does this with it. So if I plugged in 0, 0, I still get 0, 0. If I plug in negative 1, I get positive 1. If I plug in negative 4, I get positive 2. So that's what this one looks like.
So it just flips the thing.
It flips it over the y-axis if I have a negative inside. But then this last one, which is like this brownish color. Gosh, where the heck did that brown color come from? Maybe that, I don't know. Okay, so this one, if you can't see it on your paper, is really the negative square root of x plus 2. Okay? So the negative's not in the radical. We notice we have a negative x plus 2 raised to the half. That's the same thing. So, in your opinion, does this shift right, left, up, or down? Left. How many? 2. So it shifts left 2, which is great. So this is where my starting point is going to be. But then I want us to think about this. Let's plug numbers in that would make a perfect square on that one. So if I plugged in, say, negative 2, I get 0. And that's that point. If I plug in negative 1, negative 1 plus 2 is? 1. Square root of 1 is? 1. And the negative of 1 is?
Negative
1. So if I plug negative 1 in, I get to right here. All right, so let's plug underneath the radical in. Let's get another perfect square. What's another perfect square? If I plug -4 in, I still have a negative number under the radical. So let's plug in +2 though. If I plug +2 in, here, I get 2 plus 2, which is 4. Square root of 4 is 2, and then I'm going to do the negative of it. So this brownish colored one flipped over the x-axis. If I have the negative out front, it flips it over the x-axis, and then it still has the shifting. I don't know what this little question is down here. What does this do? Oh.
Yep, I do that. We don't have to go over it.
What did I do?
Just put that back.
Put it back? You don't like it? All right. What are the domains of each? All right, well, this green one has a domain of square bracket 0 to infinity because it's going to the right. This purple one has a domain of 0 to infinity. Again, we're just talking about domain. This red one has a domain that starts at 6 and goes to infinity. This brownish color one has a domain, because remember it's the x, so it's going that way. It has a domain starting at -2 and going to infinity. And then what does this blue one have for a domain? Remember, we read it left to right, so where's it coming from on the left? Where's this coming from? Where are we coming from?
Right.
Negative infinity going up to 0, square bracket. So the domain, look to where it's pointing to. Look where it's going to. That's what we're doing. So we did just the domains of each. We're good.
Then range is just like.
It didn't ask for the range at all, so we're not going to worry about it. But your range would be basically your. It would be where it starts and goes up, or it starts and goes down.
Nice.
We good? Can I move on? We good?
Yeah.
Someone saying hold on? All right. So what pattern do we do with graphing parabolas? Anyone remember? Okay, y equals x squared. What was the pattern graphing though? 1, 3, 5, right? So if you find the vertex, you go right one up 1, right one up 3 from that point, right one up 5 from that point. If it's negative, it's negative 1, 3, 5. How does the 1, 3, 5 change other than if it's positive versus negative?
Like -1.
What value changes in this equation to change the pattern graphing? Plus k. Or what changes in this equation? Ax squared plus bx plus c. What makes the pattern change?
It's A.
The a value. So it's normally the 1, 3, 5, and we multiply by whatever the a value is. Some of you are talking too much. Okay? So the a value is what influences that. So can we use those patterns for graphing a square root? I don't know. Maybe we can. So problem number 1. Where are we at here? We have a whole bunch. Okay. So let's see. Let's see. On this problem here, I want to do this. You guys making deals back there and not involving me?
They're just guessing.
Clay's gold chain.
What?
Really? I was
Wait,
there.
be in that
I was
section.
there. It's raining.
It's 1,500 Kate. Sorry.
The lady at the kiosk at the mall said
How makes it true?
you can't take a shower with her, otherwise it turns your skin green.
Dude. Now you guys are turning this conversation into no fun. Because I'm not involved.
You want to wear my chain?
Sir, can you please try on Clay's chain?
No.
Will you get it?
Alright. So
Stuart, you gotta try it on.
I'm not trying it
Yeah,
on.
you are.
No.
Yeah, you are.
Uh,
Yes,
no,
you are,
no.
Stuart. Yeah.
Yeah.
No,
I'm gonna put it on.
Stuart, you gotta try it on.
not trying it on.
Yes, you
Best
are.
Stuart as like a medal of honor. You're wearing Clay's chain.
You gotta
Clay's
get down on
chain.
one knee and let him put it on.
What?
Dude, and why are you back there reading a book? He's playing with his chain. And I don't know what the heck Kate's doing. She's probably playing with matches.
No, I'm still Spanish homework.
Oh,
I don't want your chain.
you guys doing surf class homework? He doesn't care.
It's so bad.
Feelings.
All right, so let's see if this 1, 3, 5 thing does work. Okay, so this is our parent function, right? So how we did that, we went right one, up one, right? Let's see, will the right one, up one work?
Yeah, right 3 does.
And then it technically would go this though. So from here, up one, right one, up 3, right? How many? 5 or 3?
Oh, no.
1, 3, 5. So 1, up 3.
Doesn't work.
What about this one? What about this one? So the right one, the up one, right one, I feel good about. What about this one? Would this satisfy the pattern for the second point work? Are you okay that I have a -3 for where it starts? So if I go up 2, right 1, does that kind of mold into our pattern?
Yeah.
So I think that would get us a second point. Is it going to be transpired to the whole thing? Maybe not. Well, they were inverses of each other, so maybe we have to flip-flop them. So maybe we flip-flop them. So let's see. Our pattern graph for parabolas were 1, 3, 5. And so I would go right 1, up 1. And then from that point, I'd go right 1, up 3, so on and so forth, right? But they just said they were inverses, so that's kind of like they're flip-overs of each other. So I want to see if the pattern graph works with this. So rather than doing the 1, 3, 5, using the 1, 3, 5 in that fashion, maybe if I go right 1, up 1, right 1, up 1, I think that works, and I got a dead pen, so I'm the only one that can see what I'm writing.
Right 3 up 3.
And then right 3,
Up 1.
up 1. So let's see if that works on this blue one. Okay, so up 1, right 1. And then we said what? Up 1, right 3?
Yeah.
Ooh! So up 1, right 1. Up 1, right 3. Up 1, right 5. Heck yeah. Dude, that totally works. All right, so my pattern graph on this one, rather than going, I'm going to go, hang on, did I screw my graph? So it's a 2, so I went up 2, right 1, up 1, no. I'm not, I was just seeing if I could make the pattern graph work off this, and I couldn't, I failed. So, things that we would definitely use on this one is this starts at 0, starts at -3, 0. Is that okay so far? And then to get the next point, really for direction, you would go up 1, or up 2, right 1. Because that has the 2 up front. This one here, where does this one start at? 4 and, comma? 4 and 2. So this one's gonna go upside down. So it's not. So I'm gonna go down 3, right 1. So it's opposite of our pattern graphing on this. I mean, honestly, I don't know if I would pattern graph off of these. Huh?
Wouldn't it be wider because the -3 is in front? Or wider?
It actually stretches it.
Stretches, yeah.
Yeah. So that's why it's going down 3 though. So it's going this way.
I get it. Yeah.
And then what about this one? So it starts at 0, 3. Ooh. So now I'm going to go up, half, right, 1. That one's going to be fatter. Honestly, when I would be working these, I would probably just sit there and plug values in to see if I can get a second point. I don't know if I'd follow the pattern graph. I don't know if it's going to help you real fast getting there. All right. So.
That looks fun.
All right, let's remove a few things. All right. So the purple is the parent function. Okay, it's x to the third, so it's crossing. But what do we call the kind of crossing when it's raised to the third or the fifth or the starts with a W? Wiggle. Okay, so we're gonna wiggle. So let's see. So what do you think this one would do in comparison to x to the third? Shift up, down, right, or left? Huh?
Down 4.
Down 4. So we'll take the red one and we'll put our wiggle right there. Okay? And we'll say this is the red one. It's always good when I write different colors. All right. So next one. Shh, why am I debating with people? What do you think this one's going to do? Okay, it's going to flip it over the x-axis or the y-axis? So the y-axis. So is that what we did on the last one? If we had the negative that we were doing the... Yeah, that will flip it over here. Okay, so that's blue. And then this one does what? Shifts it all up 5. So come here and up 1, 2, 3, 4, 5. Domain and range of this one when it's raised to the third power is just negative positive infinity for both of those. How many more slides I got? Too many? Really? Oh yeah, baby. All right. Okay. So what is the relationship between x to the third and x to the 1/3? They are inverses of each other. Okay. Is there any restrictions? Is there any restrictions on the purple as x to the third? So what does this graph right here look like? It actually does the same thing here, but it kind of does this.
It rotates.
It does rotate it, actually, and so if we looked at a grid, we were going to see how the values will flip-flop a little bit.
Wait, what is the green line?
It's just a symmetry line showing that's the line y equals x. So that's the most basic parent function is y equals x. And then we build from that. All right. So our black line's up there. The 1/3 x, this is my red line. This is going to go up 4. Does that. My blue line is going to go left 3. Excuse me, right 3. My green line is going to flip upside down over the y-axis, so it's actually going to go zigzag going backwards. So it's going to do like this. I can draw this halfway appropriate. And then my orange line, it shifted left 4. So 1, 2, 3, 4. And down 2. And that's what's taking place with those. Okay. So pattern, I don't know if I want to throw the patterns at. What will you use for each of these? The main thing when you're graphing this, you were looking at your 0, 0 if it was y equals x squared, or to the third, excuse me. It's the same thing if I'm looking at the third root of x, or if I'm looking at x to the 1/3 power, same thing. I'm looking at the 0, 0, and that's telling me how it's shifting. And then this half is going to make it a little bit fatter. This is going to make it, so this is going to make it stretch this way. This is going to make it stretch this way. So if I have a fraction, it's pulling out this way. It's actually called a horizontal compression. It's pushing down on it. That's why it makes it a little bit elongated. The -2 and the 3 out front, the 2 is going to flip it over the x-axis, the -2, and then the 3 just kind of stretches it out. What I'm looking at on this is, where did my 0, 0? This does a shift right 2. This just flips over the x-axis and stretches it. And then this, oh man, because I have that negative there, this is a nice curveball. Flips over y-axis because it's negative. It shifts, so that's a +5 left, 5. Shifts up 2, and then it's got a vertical stretch of 3. Ew. Maybe this lecture will clean itself up. Oh, we're done. Thank God. All right, so I got to start. Hang on first. Let me get this up for you. So we have the quiz tomorrow.
How many points is it?
455 trillion.
Sounds
So basically 8A through 8, A, B, C, D, E, F, F. That means that worksheet 8F is due tomorrow. That's your review, right? And then worksheet 8G. I'm good with evens. You good with that? Is due, what's tomorrow?
Friday?
Friday?
Thursday.
So tomorrow's Thursday, so we'll make that Friday. All right. So let's see.